Welcome to episode 10 of the present value series. So again, we have this at the end of episode 9. So in this video, we are going to get the effective interest rate represented by this X using the interpolation. And I am hoping that you also did it in advance so we can compare. Okay? Now let's interpolate after this short intro. So let's interpolate. So first, let's put the brackets. So let's start with this 8.8557 minus 8.8, okay? And we will have a difference of 0.0557. And then, the bigger brackets, we have 8.8557 minus x. And since we cannot get the answer yet, let's name it d. And let's put d here also, okay? Now, let's go to this side. So let's have first the 3,993,681 minus 4,001,069. And we will have a difference of negative 7,388. Okay? And then, the bigger bracket, we have 3,993,681 again, minus the 4 million, and we will have a difference of negative 6,319. So again, you need to be careful with the positive and the negative symbols, okay? And since we already got the two fractions, the next thing that we should do is to cross multiply to get the d. So we have negative 6,319 times the 0.0557, and we will get negative 351.9683. And then of course, negative 7,388 times d equals negative 7,388d, of course. Now, to get the d, let's divide the whole equation by negative 7,388. Okay? So this here will be cancelled. So only d remains. Okay? But here, the negative 351.9683 will be divided by negative 7,388. And we will get d is equals positive 0.0476405387. Okay? But remember, d is also 8.8557 minus x, right? So let's make the equivalence of d into an equation. So let's put this 0.0476405387 here in the left side and put the 8.8557 minus x here in the right side. Okay? Now, to get the x, we need to deduct from both sides of the equation the 8.8557. And of course, this will be cancelled out and negative x will be left. While this one right here will become negative 8.8080594613. Okay? So to cancel the negative signs, we divide the whole equation with negative 1. And we will get x, or the effective rate of 8.8080594613%. Or if rounded off, we are going to get 8.8081%. Now, that's already the effective rate and that's already the interpolation. However, let's check if this is really the effective rate that we are looking for. And that will be in a little while. So, let's check first using the timeline analysis. Okay? So, here's the timeline. And these are the interest payments. And of course, we have here the principal payment at the end of the fourth year. And of course, we also have the proceeds, or the present value of 4 million right here. And again, we know that debts and receivables grow as time passes by, right? So let's multiply the payable every year by 1 plus interest rate. And we will have times 1.088081 for 4 years. Okay? Now let's complete this timeline and see if at the end of the fourth year, this will really become 0 here. Okay? So, 4 million times 1.088081, and we will get 4,352,324. And then minus 297,500, the first interest payment, and we will get 4,054,824. And times the second 1.088081, and we will have 4,411,977, and then minus 297,500 equals 4,114,477, times again 1.088081, and we will have 4,476,884, and then minus again 297,500, and that would equal to 4,179,384, and times the last 1.088081, it will be equal to 4,547,508, and then minus the last interest payment of 297,500, and minus also the principal payment of 4,250,000, it will equal to 8.32. Well, it's not zero, but 8.32 is very immaterial. So the reason might be because we have rounded this off. Okay? So in proof number 2, let's try to use the whole 8.8080594613%. Okay? So proof number 2 will be next after this. So again, the proof number 2 is just the getting of the present value of the principal and the present value of the interest using our computed effective rate here. And after that, we just need to get their sum and see if it's really 4 million. Okay? So let's start with the PV of the principal. So 4,250,000 times 1 plus I, which is this one, raised to the power of negative 4. Now, the resulting factor for this one is 0.7134371833072. And this times 4,250,000 equals 3,032,108. So that's the present value of the principal. Now, let's go to the interest. So we have 297,500 times 1 minus 1.088080594613 raised to the power of negative 4, of course, and divided by the interest rate in decimal form. And we will have 297,500 times 3.25341601,277. And simplifying further, and we will have 967,891, which is the PV of the interest. So, PV of principal plus PV of interest, and we will have 3,999,999. So, it is short by 1, but it doesn't matter because it's very immaterial. So, with this, since our sample problem, you have two borrowing options, and the borrowing option number 1 has an effective rate of 10%, so we are going to choose this borrowing option number 2 because the interest rate that you're going to pay is only 8.8080594613%. Okay? So, the next video will be the last video for interpolation. So in that video, we will have a recap so that the process of your computation for effective rate can be shortened, and we will discuss also the getting of the effective interest rate if the maturity term is only 1 year. Okay? So that's the end for this short video. If you learned, please click like, subscribe, and hit the notification bell, and select all to be updated on my next videos. You can also comment your suggestions in the comment section below. So thank you for watching and see you on the next one.